8247 and 8248 are combined. 8247 basically is talking about systems of linear equations. Systems, more than one linear equation. So you're going to have what we normally dealt with this year is two equations on the same coordinate plane. What we found out about that is if they had no solution, one solution, or infinite number of solutions. Those are the three types that we covered. No solution, when you graphed them, both lines were parallel. Remember, parallel lines have the same slope. The solution is just basically the point of intersection, where the lines cross. And with parallel lines, they'll never cross. And the big thing there is they'll have the same slope when you put it in slope-intercept form. One solution happens when lines intersect. So that means that they would have a different slope. So the slopes have to be different. They don't have to be positive and negative. They can both be positive. It's just that when the slopes are different, lines will eventually intersect at a given point. And last solution would be an infinite solution. An infinite solution, when you put equations in slope-intercept form, they will be the same line. So once you put it in there, you would determine that the second line would be the same line, and it has an infinite number because every single point on the lines would intersect or be the same point. So infinite number of solutions. In example 1, they give us three lines, three different linear lines, 1, 2, and 3. Part A says which two lines are parallel. Well, the only way to find that out is to put things in slope-intercept form. Question 2 is already in slope-intercept form. We know -2 is the slope. So what we want to do in question 1 and question 3 is put them into slope-intercept form. Start out with the equation in question number 1. Get y by itself. Do so first by adding 6 to both sides. Next, get rid of 4x. So subtract 4x from both sides. You now have 3y equals -4x plus 6. Now you need to get y by itself. 3 is being multiplied into it. So we need to divide both sides by 3 and do that to every piece on that problem. So we have y equals -4/3 x plus 2 because 6 divided by 3 would give you 2. Same scenario for 3. Try to put that in slope-intercept form. Start out with your equation. Add 8 to both sides. Subtract 4x from both sides. Get y by itself, divide by 2. You now have y alone. So we have y equals -4x divided by 2 would give us -2x. And 10 divided by 2 would give us a +5. Next, what I did is I just put the things in slope-intercept form by each of the given numbers. So I have everything in slope-intercept form. Part A says which two lines are parallel. Remember, parallel has the same slope. So here's -2 is my slope here. Well, -2 is also in example 3. So those are parallel. So 2 and 3 would be parallel. Part B says which two lines intersect at 3, -2. The way to do this is an x value, this is a y value. Put in 3 for x into one of the equations and you should get out -2 for y. So I'll first go ahead and substitute into that first equation. The first equation we have is y equals -4/3 x plus 2. You can put it into that, or you can actually put it into the original one that they give us right here. But when you put 3 in for x, you have to get out -2 for y. So I'm going to go ahead and substitute in 3. I put in 3 for x. Now I have -4/3 times 3 is -4. -4 plus 2 would give me -2, so it would check out. So example 1 would be an option, and I will let you know that you actually need to put it into equation 2. So I put in 3 for x right up here. I have -2 times 3 is -6. -6 plus 4 is -2, so it checks out. So this would be 1 and 2 would intersect at that given point. Example 2, very similar to example B. Same thing, you need to go ahead and plug this in. Which linear system has the solution negative 3, 9? Plug that in. Plug this in for X, put it in for Y, figure out what solution that would work for. I'll let you know that it is option D. So when you put in negative 3 down here for X, we know that for Y we're going to get out 9. So right here we have negative 3 plus 12, we get 9. Checks out. We put in here negative 3, right? And we have 9 right here. So 9 is going to go in for Y. So 9 plus 3 times negative 3 is going to give you negative 9. So we have 9 plus negative 9. That gives us 0. D is our only option. With systems of equations, we need to come up with 2 equations. Example 8, Miss Peterson's math test had 35 questions. Each multiple choice question was worth 2, and each short response question was worth 5 points for a total of 100 points. How many multiple choice questions were on the test? So here's what we need to do. Come up with the amount of questions. The amount of questions is 35. Well, how do you get those questions? Well, they were multiple choice plus the short response. So those would give me 35 total questions. Next, we know that it is 2 points per multiple choice plus 5 points per short answer. That would give us 100 points. So now we have 2 equations here, and we use substitution before and also elimination to figure out what these values were. So I'm going to go ahead and use elimination. Elimination. Draw a line underneath. Well, I'm going to eliminate m's. In order to eliminate m, I need to have that become a negative 2. So I need to multiply this whole equation by negative 2. When I do this, I get now a negative 2m, I get negative 2s, and I get negative 70. Now you have a new problem. This is no longer an equation. Here's my 2 equations here. I'm going to go ahead and eliminate my m's. Boom. 2m minus 2m. Taken out. 5s take away 2s is 3s. 100 take away 70 is 30. Divide both sides by 3 to get s alone. We find out s equals 10. So I have 10 short answer questions. I need to figure out how many multiple choice questions there are. So it says right here, how many multiple choice questions, right? Well, we know that there are 35 total questions. 10 of them are S, short answer. So multiple choice would be 25. This concludes the standard 8247 and 8248.